All right, strap yourselves in because today we are going deep, really deep, into some pretty wild claims about what's happening out there in the solar system. Changes so big, so fast, it's almost like the planets decided to hit the fast forward button on evolution, wouldn't you say?
It really is remarkable. The data we're seeing, it points to warming, atmospheric shifts,
Yeah.
magnetic transformations even, and not just on one planet or moon either. It's system-wide, like some cosmic force is orchestrating this grand shift across the entire solar system.
Now, our source for all this cosmic drama is, well, a video by David Wilcock, who claims he's got his hands on some leaked NASA files. And full transparency here, Wilcock connects all this to some, let's just say, far-out theories, like a hidden companion star he calls the Black Sun and a coming golden age. But we're going to park those ideas for now, okay, and focus on the science, the data, the actual observations that NASA made. What do you say? Shall we stick to the facts and see where they lead us?
Absolutely. Let's let the data tell the story.
Okay, so picture this. Cosmic tour of our solar system, hitting all the hot spots where things are getting weird. First stop, Mercury, zipping around the sun like a little silver bullet. Back in the 70s, Mariner 10 flew by, didn't detect any magnetic field at all. But then, fast forward to 2008, the MESSENGER probe discovers that Mercury has, well, it sprouted a magnetic field, like a cosmic teenager suddenly hitting puberty.
Yeah, it's like Mercury decided to completely reinvent itself overnight. And it gets even stranger. Just a year later, they discover what they call magnetic tornadoes swirling around the planet.
Magnetic tornadoes. I mean, what? Okay, onto Venus, shrouded in thick clouds, surface hot enough to melt lead. But something strange is happening there, too. Between 1978 and 1999, its green night side glow, which comes from oxygen emissions, get this, increased by 2,500%.
That's not just a little tweak. That's a full-blown atmospheric makeover. Makes you wonder, could Venus actually be becoming more hospitable to life? It's a long shot, sure, but the fact we're even asking that question shows how much our understanding of Venus is changing.
Okay, next up, the red planet, Mars. Between 1975 and 1997, clouds and ozone, they just appear out of nowhere, it seems. Plus, evidence suggests that its polar ice caps are melting. And you know what NASA calls it? Global warming. Makes you think, doesn't it, considering there aren't exactly any Martian SUVs spewing out exhaust fumes?
It is a curious choice of words, isn't it?
Yeah.
You have to wonder, are they seeing parallels between the changes on Mars and what we're going through here on Earth? Even if the underlying causes might be totally different.
And then there's that massive dust storm that engulfed Mars in 2001, so big scientists said it would have wiped out life on Earth had it happened here.
A sobering thought, for sure. Really drives home the point that our solar system is a much more dynamic and unpredictable place than we tend to give it credit for.
All right, buckle up. We're heading to the king of the planets, Jupiter. Now, sometime after 1974, Jupiter develops this plasma torus, which is basically a giant glowing ring of charged particles. And between 1979 and 1995, this torus increases in density by, get this, 200%.
It's like Jupiter suddenly decided to crank up the volume on its energy output. And remember those three heat vents on Jupiter's surface, they merged into one giant vent in just 3 years. Some think this caused a major temperature spike, maybe as much as 18 degrees Fahrenheit.
And as if that wasn't enough, in 2008, Jupiter experiences what NASA calls a global upheaval. Raging thunderstorms, massive temperature swings, its entire atmosphere basically gets reshuffled.
And we can't forget about the impact on its moons. Jupiter's gravity is so strong, these changes could be having a ripple effect across the entire Jovian system.
You're right, Jupiter's moons are definitely part of this story. Let's start with Io, the closest one. Between 1973 and 1996, its ionosphere, that's the charged particles in its atmosphere, jumps up 1,000% higher.
It's like the moon suddenly got this giant invisible force field. And on top of that, the surface temperature on Io spikes by over 200% between 1979 and 1998. We know Io is volcanically active, but these changes suggest something much more dramatic is going on.
Now, on to Europa, another of Jupiter's moons, and this one's a real head-scratcher. When the Hubble Space Telescope takes a look, Europa is glowing, much brighter than anyone predicted.
It's like someone switched on a cosmic nightlight. And this glow, it points to some intense energetic processes happening within Europa, maybe from Jupiter's tidal forces or even internal geological activity. Makes you think Europa might be even more dynamic than we ever imagined.
And then there's Ganymede, Jupiter's largest moon. Not to be left out of the party, its brightness doubles, and its atmosphere becomes 1,000% denser between 1979 and 1995. It's like all of Jupiter's moons are going through a synchronized transformation.
It does seem that way, doesn't it? You have to wonder if it's all connected to Jupiter's own changes, maybe even tied to that increased solar activity Wilcock was talking about.
Okay, last stop on our whirlwind tour, the ringed wonder, Saturn. Now, between 1981 and 1993, its plasma torus, that glowing ring of charged particles, grows 1,000% denser. And then they find another one, even bigger.
It's like Saturn decided to double down on its cosmic jewelry. But what's really mind-boggling is the speed of these changes. We're talking massive structures appearing in just a few years, events that, by all accounts, should take centuries, millennia even, to unfold. It's like someone hit the fast-forward button on planetary evolution.
And just when you thought Saturn couldn't get any more dramatic, in 2004, a giant burst of X-rays erupts near its equator. And then, in 2010, a storm erupts that was so large it would have covered most of North America if it happened here on Earth.
Yeah, that storm was a real enigma. It defied our understanding of how weather works on Saturn. Like something fundamental shifted in its atmospheric dynamics.
So there you have it. Planets growing magnetic fields and tornadoes, moons glowing in the dark, wild temperature swings, storms erupting across the solar system. It's a lot to take in, isn't it? What do you make of it all?
Well, it certainly challenges everything we thought we knew about our solar system. It's not this static, unchanging place we once imagined, but a dynamic, evolving system full of surprises.
It's like we're watching a cosmic drama unfold in real time, wouldn't you say?
Absolutely. And like any good drama, it's full of twists and turns. Who knows what the next chapter holds?
Well said, well said. We'll be diving deeper into this mystery in just a bit, so don't touch that dial, folks. So we've got warming, we've got atmospheric changes, magnetic shifts, even X-ray bursts. I mean, it's a lot, right?
hmm
Is there a common thread here, or are we just looking at a bunch of random cosmic coincidences?
Well, when you consider the sheer scale and the speed of these changes, it does make you wonder if something bigger is at play, wouldn't you say? As if the whole solar system is responding to some kind of, I don't know, a cosmic conductor, if you will, leading this grand symphony of change.
And that brings us back to, well, Wilcock's theory, right, about increased solar activity. He claims it's the highest it's been in 8,000 years based on ice core data. So could the sun be that conductor?
It's certainly a possibility. I mean, the sun, it's a powerhouse, right? Even small fluctuations in its activity can have huge ripple effects across the entire solar system.
So, like, the sun sneezes and Jupiter throws a tantrum.
Uh-huh. In a very simplified way, yes. The sun's increased energy output, it could be triggering these changes we're seeing. The warming, the atmospheric shifts, maybe even the magnetic transformations.
Okay, that makes sense. But what about the speed of these changes? I mean, we're talking planets and moons transforming in a few years. Isn't that insanely fast on a cosmic timescale?
Absolutely. That's what's so remarkable about all of this. It really challenges our traditional understanding of planetary evolution, which, usually unfolds over millions, billions of years.
So what does this mean for the future then? If the sun is really ramping up its activity, does it get, even crazier from here?
That's the million-dollar question, isn't it?
Yeah.
We know that solar activity is cyclical, with periods of higher and lower intensity. But this current cycle, it seems to be more intense than anything we've seen in recorded history.
So are we talking like a doomsday scenario here? Giant storms wiping out Earth, planets colliding, that sort of thing?
Let's not get ahead of ourselves. It's important to remember that while these changes are significant, they're not necessarily catastrophic. In fact, some of them could be beneficial. For example, those melting ice caps on Mars, they could create new habitats for life, potentially.
Okay, so maybe not a cosmic apocalypse, but definitely a cosmic makeover.
Exactly. We're entering a new era in the solar system's evolution, one that's more dynamic, more unpredictable.
So what about us here on Earth? Are we immune to all this solar craziness?
Not necessarily. We know that solar flares and other solar events can disrupt our satellites, our communication systems, even our power grids. As the sun gets more active, we could see more of those disruptions.
So more blackouts, more internet outages, fun.
Yeah, not exactly ideal. But there could be positive effects too. Some studies suggest that increased solar activity can actually stimulate creativity and innovation in humans.
So maybe a surge in technological advancements. Silver linings, right?
Exactly. It's all interconnected, you see. The sun, the planets, us here on Earth, it's all part of this intricate cosmic dance.
Okay, before we get too deep into the existential stuff, let's circle back to Wilcock's theories for a moment. This black sun, this golden age, any scientific basis for those ideas, or is it all just, speculation?
Well, the idea of a companion star to our sun, it's not entirely out there. Some astronomers believe that our sun might actually have a dim, distant companion star orbiting it.
But what about the Golden Age stuff? This idea that this companion star is going to trigger some kind of spiritual enlightenment and technological revolution here on Earth.
That's where we move into the realm of speculation. While it's fun to consider, there's no scientific evidence to support that idea.
So for now, we'll stick to the data, right? We'll marvel at these incredible changes happening around us, even if we don't fully understand them yet.
Absolutely. There's still so much to learn, so much to discover.
And that's what makes it so exciting, right? But what about you out there listening? Does this make you question everything you thought you knew about space? Are you curious about what the future holds for our solar system? And what about life beyond Earth? If these changes can happen here, what might be happening in other star systems across the vast universe?
Makes you realize we're not just living on a planet, we're part of this whole incredible dynamic system, constantly evolving, changing.
Yeah, it's like our cosmic address just got a whole lot more interesting, not just Earthlings anymore. We're solar system citizens connected to all these wild events happening around us.
And who knows, maybe those events aren't so random after all. There's this idea, some scientists are exploring it, that the sun's activity, it might actually be influenced by even larger cosmic cycles,
Right.
like the movement of our solar system through the galaxy.
Whoa, okay, hold on. Now we're getting really mind-bending here. So galactic forces are pulling the strings, the sun's dancing to their tune, and the planets and moons are putting on a show for us.
Uh-huh. It's a fascinating concept, isn't it? It shows just how much we still don't know about the universe, how much we have to learn about our place in it all. There could be forces at play that we haven't even begun to imagine.
It's exhilarating, sure, but also kind of terrifying, Like realizing the stage is way bigger than we thought. There are all these actors we haven't even met yet.
Exactly. But that's what makes exploration so exciting, right?
Yeah.
The unknown. That's where the greatest discoveries are waiting for us.
Well, you've definitely given us a lot to think about, from magnetic tornadoes on Mercury to glowing moons around Jupiter, and the idea that, well, the sun might just be a pawn in this much larger cosmic game.
It's a wild ride, that's for sure.
It really is. I think the biggest takeaway for me, and maybe for our listeners too, is that we're not just observers of all this change. We're participants, right? Whatever happens on the sun, on other planets, even in distant galaxies, it can have an effect that reaches us here on Earth.
Absolutely. It shows how interconnected we are with the cosmos in ways we're just beginning to understand, I think.
So, as we wrap up this deep dive, I have one final question for you out there listening. What if this is just the beginning? What if these changes we're seeing, what if they're just a prelude to even bigger, more profound transformations in our solar system and beyond?
Now that's a thought, isn't it? As we continue to explore, to learn, we might find that the universe is far more wondrous, far more interconnected than we ever imagined.
Well said. That about wraps it up for this deep dive into the mysteries of interplanetary climate change. We hope you've enjoyed the journey, and maybe, just maybe, you've come away with a little bit of awe, a little bit of wonder about our place in this vast and ever-changing cosmos. If this deep dive has sparked your curiosity, well, keep exploring. Keep searching for those answers to the mysteries of the universe. Until next time, keep looking up. And keep those minds open to the infinite possibilities that await us out there.